Hey guys, it's Mrs. Moylan, and we are going to work on some prime factorization today. Remember in class we talked about a way to remember the first few prime numbers. So here's our sentence. I'll meet you at 7-Eleven at 2:35 to buy 13 Slurpees. So that's a fun way, an easy way to remember that 7, 11, 2, 3, 5, and 13 are all prime numbers. So anything in your prime factorization answer has to be prime, otherwise it's not prime factorization. So let's just review how to do the factor trees. I'm starting with the number 30, and I think of two factors of 30. And I know that 5 times 6 will give me 30. Now 5 is what kind of number? Prime beef, so we circle it. 6 is not prime, it is composite. So I'm going to put a square around it so I remember that I have to keep working with it. I look at 6 and I think, okay, what are two numbers that can go into 6? What are two factors of 6? And I know that 2 times 3 will give me 6. Now I look at those two numbers and I see that 2 is prime beef and 3 is prime beef. So I circle both of those. Now that everything's in a circle and there's nothing left to keep factoring, I can write out my prime factorization in a multiplication sentence. We start with the smallest number, which is going to be 2. We multiply that times 3 and then times 5. Another way of seeing this will be with the dots. So it'll be 2 times 3 times 5. Those dots mean the same thing as the x's. So that's two ways of looking at it. If I wanted to check my work, I could check it by saying 2 times 3 times 5 and multiply that out. 2 times 3 is 6 times 5 equals 30. So that's a way that I can check it. Let's look at the other way, which was the birthday cake method. So if we look at the birthday cake method, it's the same thing, except when you're factoring it, you always have to have at least one prime factor. So one prime factor that will go into 30 would be 2, because 2 is prime and it goes into 30. Then I think of how many times? 2 times what? 2 times 15. 2 is prime, of course, it's on the side. 15 is not, so I have to keep factoring. And I think, again, what's a prime number that goes into 15? I know that 3 goes into 15, and it goes in 5 times. I keep factoring because I'm not up to my candle yet. So 5 is a prime number that goes into 5, and it goes in 1 time. Remember that 1 is not a prime number or a composite number. So we're really just trying to put the birthday candle on top of our birthday cake, and then we've got our birthday cake right there. Again, write them in order from least to greatest, and it looks like that. Or you can use the dots. 2 times 3 times 5. 2 times 3 is, of course, 6 times 5 brings me back to 30. So the answer to this question would be right here. 2 times 3 times 5 is the prime factorization of 30. Okay? So we talked about that in class. Let's talk about something we didn't discuss in class, which is exponents. Okay, so we're going to look at a more difficult number, a bigger number that has more factors to it. So we're going to start with 100. I want to think of two factors of 100, and they don't necessarily have to be prime factors. So I'm going to go with 10 times 10. Now I know that both of those are composite numbers, which means I need to continue factoring both of those. So I'm going to keep going with 10, and I know that 2 times 5 equals 10, and again 2 times 5 equals 10. All of these are now prime beef, so I circle them. That tells me that I'm done factoring 100, and now just to put my sentence in the right order. So I put 2 times 2 times 5 times 5. Now, when I've got repeats of numbers, I can use something that's called an exponent. And an exponent is just a little tiny number to the top right-hand side of a base number. So I look here and I see, well, I've got 2 times 2, so I can show that by writing 2 with the exponent of 2. Another way of saying that is 2 squared. I also see that I've got two 5s. So I'm going to write that using an exponent. I've got 5, and it's showing up 2 times. So those are exponents. It means the same thing as that, 2 times 2, and this means 5 times 5. Okay? If I were to work those out, 2 times 2 is 4, and 5 times 5 is 25, and 4 times 25 is 100. So that brings me back to where I started from. So in this case, the final answer would be 2 squared times 5 squared. That's the prime factorization of 100. Okay? Let's try it and look at it with the birth method. So here's our 100. And this time, remember, it's got to be a prime factor on the outside of the cake. So I've got, let's see, what have I got? What goes into it? I know that 5 goes into 100, and I know that it goes into it 20 times. I know that 20 is composite, so I have to continue with my division. 5 goes into 20, so I'll just use that same prime factor again. 5 goes into 20 4 times. Keep going with my division because I'm not to the candle. 2 is a prime number that goes into 4, and it goes in 2 times. Not to the candle yet. 2 is the only prime number that goes into 2, of course. That leaves me with my candle. Light the cake on fire and continue down because I like to make it look cute. Okay? Same thing. I'm using the numbers on the left and writing them in order from least to greatest. So 2 times 2 times 5 times 5. Looking at the exponents, I have 2 2's, so that's 2 2's. And I have 2 5's, so that's 5 is the base number, 2 is the exponent, and I multiply them. So the prime factorization of 100, again, is 2 squared times 5 squared. Let's look at it from the other direction. Let's say you have a number sentence and it's got exponents in it, and it's saying, it would say something like 3 squared times 2 cubed, that's what it means when there's a 3 as the exponent, is the prime factorization of what number? So you have to be able to work them the other way, from the expression to the composite number. So we'd write it out. This means that there's 2 3's. And this means that there's 3 2's. So 2, 2, and 2. And I'm going to multiply it all together. Once I write out my sentence, I can just multiply from left to right. 3 times 3 is 9, and I bring down everything that I didn't use. 9 times 2 is 18, and I bring down everything that I didn't use. 18 times 2 is 36. Bring down the 2 that's left, and 36 times 2 is 72. So that means 3 squared times 2 cubed equals 70, oh my goodness, not 75, equals 72. Oh goodness, what did I do? Here we go, 72. Okay, so that's, there's 2 ways that you can look at it, from the composite number down or from the expression up. Here's just a few things to remember. When you're doing the prime factorization, you want to put a square around your composite numbers to remind you to keep working with them. Put a circle around your prime numbers and feel free to yell out prime beef. You want to remember that you've got base numbers. That's this 2 over here. This is a base number. And this 4 up here, that's an exponent. The exponent tells you how many times you're multiplying the base number. So this really means 2 is multiplied 4 times. It doesn't mean 2 times 4. So that would mean 2 times 2 is 4, times 2 is 8, times another 2 equals 16. And we're going to practice this some more in class, but now you've got a good understanding of exponents.